I've been working off and on with Q-Sys a fair bit in the past few years, and I've really grown to love the platform. One of my favorite features is control scripting. I had never worked in Lua before, but honestly, it's been a pretty good language to write scripts in, and coming from the C family of languages, I found myself naturally being able to follow how it works and create some very useful scripts with it, with very little extra training. However, up until recently, there's been one interest of mine that I've not been able to work with: plugin development. In the past few years, there's been a growing base of knowledge on developing plugins for Q-Sys publicly available on the internet, but it's still pretty limited. I wanted to create videos for people interested in developing Q-Sys plugins who are having a hard time getting started. So today, I'm going to walk you through the development of a simple plugin and demonstrate how it works. Now, a quick disclaimer. I'm not very experienced in developing Q-Sys plugins, and I'm still learning it myself quite a bit. So the things I do might not be the best way. Even more importantly, this is a basic tutorial. There are a lot of things here that I will not cover. Hopefully, I'll be able to get into them at a later time. Now, I mentioned earlier that there was some information on developing plugins, and I wanted to point out 3 references. The first one, of course, is the Q-Sys help system. This reference contains the Lua reference manual as it pertains to Q-Sys. There are some slight differences to normal Lua just because of the way they've implemented. It also contains the Q-Sys extensions to Lua as well. If you've done control scripting before, you should be familiar with this. The second is a GitHub repository from q-sys-community, an online community with resources and plugins for Q-Sys development. We will use some information from their Q-Sys plugin guide to get started, namely just getting the correct plugins, getting the right configuration for Visual Studio Code, and just being able to get started into that development. And lastly, there's a GitHub user by the name of gdyr who has a repository called Q-Sys Plugin Docs, which contains quite a bit of information on all of the options available for controls, properties, etc. So in order to get started, you're going to need 2 pieces of software: Visual Studio Code and, of course, the Q-Sys Designer. I'm using version 9.3.1 of the Designer, but whatever version you have should work as long as it's moderately recent, although there may be some differences. So the first thing we'll do is open up Visual Studio Code and go into the Extensions tab. There are 3 different extensions recommended by the Q-Sys community. There's Markdown All-in-One by Yu Zhang, Markdown Lint by David Anson, and VS Code-Lua by Trix NZ. Once you have these installed, you're going to go to File, Preferences, Settings, and then you're going to click this button up in the top right, which when you highlight over it, it'll say Open Settings JSON. And you're going to add this file association section. Q-Sys plugins by nature use the qplug extension by default, although you can use a .lua if you'd like. It's better to go with the qplug, just for clarity's sake. And this association will allow Visual Studio Code to open the qplug files as Lua files and process them as Lua files. So we'll go ahead and create a new file and we'll get started. Now, I like to follow the doctrine of save early and save often, so the first thing we're going to do is save our file. I created a separate folder for storing plugins under development outside of the Q-Sys Designer plugin folder, since Designer will reparse and recompile your file every time you save it, and if there's anything wrong with it, it'll just keep chucking errors. And I've even had Q-Sys Designer crash a few times because of some error in my plugin code. So I made a Q-Sys plugin folder in my documents. That's where I keep the ones that I'm editing. And then once you're ready to test your plugin, you're just going to copy it over into the Q-Sys Designer plugin folder, which is usually found under Documents, QSC, Q-Sys Designer, and Plugins. And it'll automatically come up in Designer. I should note that any graphical changes made to your plugin will require that you remove any instances from your design and re-add them. Any runtime changes might update on their own when you re-emulate or re-download a design. I haven't had a whole lot of luck in this, but I have heard that it would work, and it's something I need to look into a bit more. For the file name, I like to keep it simple, just what the plugin is, and add a version number, so that when in the future, if you're doing multiple versions of your plugin, maybe they need to interact with different versions of hardware or different firmware versions of external devices. That way your users can keep track of which plugin version they're using. So once it's saved, I'm just going to open up my template file here, which I'll post on my GitHub, and just copy over the contents of that just to make things a little bit easier. So this is a good time to talk about what our plugin will do. We're going to keep it simple today. We're going to add a status box, an LED whose color will change with the status, a knob, and a numeric entry text box, and those last two are going to be using integers. When the knob value is changed, it's going to be checked against the text box, which we'll call our set point. If the value of the knob is lower, we'll set the status to fault. If the value is higher, we'll set it to compromise. And if they're equal, we'll set the status to OK. I know it's not the most practical plugin, but it'll get the point across. The first section that Q-Sys needs is the plugin info. We'll give it a name, which is what will show up in the plugin list in the right sidebar. We'll call this one basic plugin, but we're also going to add my name followed by a tilde before the plugin name. The tilde character is a folder separator in Q-Sys and will allow us to organize our plugins in the specific folder within that plugins pane in Q-Sys Designer. The next thing we need to do is set our version number. In this case, we'll use 1.0.0. Next, we need an ID. This doesn't really matter. It just needs to be unique from other plugins. Nothing special. I've seen company names dot the plugin name dot the version. I've seen GUIDs. I've seen all sorts of things. I'm just going to go with a GUID today. So I'll pull up an online GUID generator from the internet, and we'll go ahead and grab one and paste it in here. After that is a description. Now, if you haven't worked with Lua before, you'll notice these double square brackets I have here instead of quotes. The double square brackets allow you to create a multi-line string. So because we're doing a description, it's usually a bit long. I like to just have the double square brackets just to keep things neat. Of course, we'll need to add an author, which is going to be us. And finally, you see this show debug option here. When you have this set to true, it'll allow us to open a debug window to view errors, debug print statements, etc. from the properties pane. The next section is some global data that I've added. These ones I just put in here are constants to be used in the script, and I've got some color options as well as the numeric value of the different status indicator states. We'll be using those later. Following that is our next Q-Sys required section, and that is the properties. Properties are what you see when you're in design mode and you click on a component block on the design sheet. The right sidebar will allow you to set some settings which cannot be changed during runtime, so in this case, they act like constants. The first function we'll use here is called getProperties. Q-Sys will call you when you first pull the plugin into a design and use it to set up the properties. We're going to add two properties here, get the minimum and maximum range of the knob and the set point text box. We'll start by adding this new table in the props table, give it a name, which this is what's going to show up in the right sidebar, but it's also going to be used in code to reference the property. You can put spaces in here, and I'll show you how to reference this name later. We need to set a type, which will be integer here. Notice the capitalization. There is actually a funky thing when you do integers in properties versus controls. You have to watch your capitalization. And for the minimum and maximum of this property, we're going to go with 0 to 65,535. Lastly, we need to set a default value, which is going to be 1 for the minimum and 10 for the maximum. The next function shown here is called rectify properties. We're going to skip that one today and we'll move on. The next thing we need to set is the pretty name of the plugin. This is the default name on the block in the designer sheet and will also show up when you open the controls window. You'll see that this props argument is available in this function, and we actually used the same name in the last function. This is the table that gets passed around as the design takes place and everything gets put together. It contains all of the properties previously set, and any function that uses it will generally have the same behavior as rectify properties, where it will be called anytime a property value is changed and after the block is pulled into the design. This means that values of properties are available to our pretty name and we can use them, which we will here. And we'll actually give this a name of basic plugin, a colon, then we'll put the minimum value, we'll have the word to, and then we'll put the maximum value, just so we can see how these change when you change the properties. The next thing we have to set up are the controls. These are the knobs, buttons, and switches that make up the front and back end of the user interface. First, we'll set up the back end with the getControls function. We'll define a table called CTLS and start filling in the controls. Firstly, the control name is not a pretty name, and so you don't have to worry about spaces or making it look nice. This is what we're going to use to reference later in the code, so make it easy to reference. Now, I won't get into control arrays today, so all of our controls will have a count of 1. There are a few different control types, and today we're going to be using 2 of them, indicators and knobs. When you set a control as an indicator, you need to give it an indicator type. In this case, we will use the type status for a status box and LED for an LED. The last 2 settings are whether or not the user should be able to enable and disable the control pin and what pin style the control will have. If you set user pin to false and you give it a pin style, the pin will be there under the block, the user will be able to wire to it, but they won't be able to hide it or disable it. If you set user pin to true and you give it a pin style, then the user is able to click the checkbox in the control pins in the pane under the plugin properties to enable or disable the pin. For knobs, we're also going to need to set the control unit as well as the minimum and maximum value, which we'll use those properties that we created earlier to define this range. One thing you'll notice is the last control is called setPoint box, but I defined it as a knob. Since we only want integers to be entered, the type is knob, the unit is integer, and we will later define the front end as a text box, so you can see how the controls and the actual graphic control display can be different depending on what kind of behavior and how you want your plugin to look. It's perfectly valid. Last, we'll return this table that we defined, and that will set up the controls in the back end. Now we have one more Q-Sys required section that we're going to actually be working with today, and that is the control layout. Big surprise, the function's called getControlLayout, and we're going to be creating 2 tables here actually. The first is layout, which is the actual front end version of the controls, the stuff your user can interact with, and the second is graphics, the things that make your layout segmented, labeled, and overall prettier. For the layout, we'll create an empty table and we'll define our elements separately using the name of the backend control as the array index, which is the thing we're putting in the square brackets. Every control should get a pretty name, a position, a style, and a size. For this plugin, we're going to use text for the status box, which is generally what you'll see. We're also going to use it for the setPoint box, which, remember, we defined that as a knob on the back end, but it's going to be a text box here. We're going to use a type of LED for the LED and knob for the value knob. Now, anywhere there's text, I like to set the font size, whether word wrap should be used, and the isBold property. For the graphics table, we're going to give it 2 labels so the user knows what the value and setPoint controls do. Since we don't need to associate these with a specific control, we'll go back and use the same style as we did in our properties and just define these inside the table. The type of these will be label. We're going to need to give it a size and a position, And since we're doing labels, we need to give text a text size. And in this case, we're going to override the horizontal alignment so that they're right aligned. Now there are a few more functions down here. We're going to go ahead and skip over these today. They're not really that important for what we're doing here. And if I keep scrolling down, you'll see I have two other functions here. I just like to have these in my template for dealing with colors. Now we get into the fun stuff, the runtime logic. We're going to keep it simple today. There are three major things you need to remember when it comes to runtime logic. Any runtime logic that is not inside of a function must be in this if controls then block. This will only run when the controls table is defined, and that's during runtime. The second thing is that properties and controls are now available in a table with a matching name. And lastly, logic here is event handler based. So anything outside of a function will run once during startup, and then everything else only happens during event handlers. There is no normal loop, and do not try to create a recursive loop or any sort of running loop that will just keep running over and over again, because Q-Sys will throw an error that the maximum execution time has been exceeded. If you need things to happen in a loop, what you can do is create a timer and have a function called when it elapses. So the first thing that I like to do for runtime is to give my properties that will be used by the runtime logic nice names. Since they're acting as constants, I'll go ahead and put them in all caps because that's how I usually style things. The second thing we're going to do here is perform an assertion, which this is going to make sure that the minimum value is less than the maximum value. And what an assertion will do is if the first argument is not true, it will throw an error, and the error text will be what the second argument is. And so in this case, the first argument is minimum value is less than maximum value, and the second argument is this nice message to the user. So the next thing we're going to do, and actually the last part of our runtime startup logic, is to attach an event handler to the value knob. We're going to call this handler value knob changed, and next we'll go ahead and create a function above, remembering that the functions don't have to be in the if controls then block. It's code outside of the functions that has to be in there. Any control event handler has one argument available, which is going to be the control that triggered the handler. So what we're going to do is we'll create an if-else statement with the following logic that we mentioned earlier. If the value knob is lower than the set point box value, since in this case, the value knob is what called this function, we can just use this CTL. In that case, we're going to set the status to false, and we'll adjust the LED color to match. If they're equal, we'll set the status to OK, and if the knob is greater, we go to the compromised status. Very simple, and that's the end of our runtime logic. So let's go ahead and try it out. I'll save the file, go into File Explorer, and copy it into the Q-Sys Designer plugin directory, and then we'll open up Q-Sys Designer, and we'll drag the plugin right on in. You'll see that the pin for the value knob is visible. Since we set its user pin property to false, the user can't disable it, and we gave it a pin style, so it's going to show up there. The properties contain the minimum and maximum value, and if we go ahead and change the minimum, you'll see it updates the name in the block. Below the properties, you can see that status pin that we allowed the user to enable and disable. And that's it for our setup. So let's go ahead and emulate, and we'll open up the block. You can see that the value and the set point are set to our minimum value. And the first time that you run your code after pulling the block into Designer, they're going to default to the lowest available value. So I'll go ahead and change the set point, and you'll notice the status box didn't change. Remember, we only attached a handler to the value knob, so we'll go ahead and change the value knob around a few bit, and we can see that the status box and the LEDs are changing following our logic. Well, that's it. That's a basic introduction to Q-Sys plugin creation. Like I said, there are a lot of things that I haven't covered. Hopefully, I'll be able to do more videos in the future to expand on the knowledge. If you have any questions or comments, go ahead and leave them below. Thanks for watching.